So as it says, dear calculus creators, the name is Clulus. Clulus. As you well know, I'm investigating the alleged criminal violation of the posted speed limit by Katie Harvey, former principal of the local high school. You can probably imagine the immense scrutiny this case will undergo when you consider the magnitude of her influence and stature in the community. I have requested the help of Dr. Bill Pye, the math guy, but he is currently busy and has suggested you as the next best group of people to help. I will fill you in on what I know and what information I need. Officer Justice, using his very sophisticated radar equipment, was able to determine the speed of the vehicle in question going 42 miles an hour at 3:17 and 19 seconds while passing the first safety checkpoint. Half mile down the road, Justice's partner clocked the vehicle going 43 miles an hour at 3:17 and 49 seconds while passing the second safety checkpoint. Dr. Pye claims it is a mathematical impossibility to travel that distance in that interval of time given the constraints of the posted speed limit. Can you help me understand what this might mean? Does it have something to do with derivative? From what I understand, that's the word for the day. Dr. Pye managed to provide some guidance for your investigation in the form of the attached document, which is what I handed out to you. I desperately need your world-renowned expertise in providing the mathematical proof to build my case. In my opinion, it won't be hard to prove that this maniac was speeding. Not only that, I believe deeply that we have a strong case of criminal speeding going at least 20 miles over the speed limit to bring before Judge Dredd. However, I need to understand the math involved in order to clearly explain it. Please show all symbolic, graphical, and numerical work so that I can understand and present this information in court. Remember, I am clueless. Clueless. He's a PI for pie. So I didn't write the information for you, so can you guys fill in the data from the up here? I'm sorry, up there. So get the time checks. And then work with your table to answer the next several things on your sheet. Okay, you guys have the data written down? Not yet, we're still working. I want to change the page. Okay, does everybody have the 2 data points, which is what you need? Oh, how far were the checkpoints? Half mile? What you thinking? So it asked you to calculate the slope.
Yeah. Well, you always true me out. It's the one just divided by 30 is 15.
I think it's just the average. Like we're not doing the derivative. What the number is.
Is that what we're struggling with?
No, that's not, we're not sure. Yeah.
It's not fluctuate.
Do you have to convert it first?
FLUC.
No, you convert afterwards, just read it.
Okay, now it's my question.
Yeah, it's not that bad.
Has no units written on there, which makes it really confusing. So she did half a mile in 30 seconds. What's her speed in regular old miles per hour? 60 miles an hour.
So what a criminal.
Because what's this posted speed limit?
43. Or wait, what?
She was doing 42 and 43 when she was clocked. But
Nice.
the slope of this straight line, we just calculated it, is 60. She started off doing 42, and then 30 seconds later, she was doing 43.
The average is 60.
The average is 60, what the heck?
I mean, she like went way over
Well,
to get the average
break it
down
half.
to 60.
Yeah, yeah,
She
yeah.
got
I mean,
like-
she
she
went-
got like 75 or something.
She was a screaming demon, she should be locked up.
But we don't actually know the acceleration of the car, we don't actually know the top speed, just we know it's over 60.
Which is why the thing said, I believe we have a really strong case
Yes.
for criminal speeding. Like, but do we know exactly? No, but my girl,
Almost.
she should be locked up.
Hey, she could be an anomaly in physics and be able to accelerate to 50 or 60.
She's an anomaly, I'll give you that. Ah. So was it possible for her distance travel to go in that straight line as it was, that we drew on the first thing? But Jessica's like, no. Anyone, can you draw what you think would be her possible, well, I thought you would, yeah.
You just figured it out, bro.
Is it like a upside down parabola?
So, could it be that?
No.
Why not?
Oh, it was backwards.
So, they mean she went, because this is distance, so it means she went past the checkpoint and then came back? Yeah.
Yeah, I'm pretty sure it doesn't, shouldn't it start below the line because she was going 42 at the checkpoint? So the line should probably start a little below the line, then go above the line, then go back below it at the end.
So, do I have to stay sandwiched in between 0 and half a mile? Could-
No.
Could she have like thrown the car into reverse and then gone like ahead of, like, could you,
No.
I mean, I know this lady, she might have done that, but, okay, but, so, yeah.
Maybe like up slowly and then up really fast and then slowly.
So that's, I think what Ben was explaining. He said, well, it started off, it's gotta be, her average speed to start, her clocked speed to start was 42. So it's gotta be a smaller slope. And then he said, just like you, she had to be a screaming demon at some point, so that for 42 or 43 mile per hour average, came out to be 60. But then she slowed down at the end because she was like, oh, there's another checkpoint, I better get within the speed limit. Roar. Is there any other way we could have drawn this?
based on the situation.
not uniquely, okay, so the constraints, she wouldn't have gone below the x-axis and she couldn't go, or doesn't make sense that she drove past and then came back. So it's gotta stay constrained in there. She started off with a slower slope and ended with a slower slope. Her speed right there, crazy wicked, lock her up. Okay. So this is also asking, on the graph that you drew, sketch a tangent line to the curve that's parallel to the original line. What does that mean, those purple lines? What are the slopes of those purple lines?
Same.
Same as the secant.
Oh, yeah.
And what was the slope of that secant line?
60 miles
60.
an hour.
Okay. So right here, if this is her graph, she had to have been doing 60 miles an hour. Was there, Felipe, was there a time that she was like faster than 60?
Really?
Probably. Like, yeah, in there. Okay. So, did you have to, like, put in a court of law, would we be able to argue that she absolutely was doing 60 miles an hour at some point?
Yeah.
Yeah. Okay, and the reason is this thing called the mean value theorem. Is speed, or velocity I should say, continuous? Could I go from 0 to 50 miles per hour and skip over doing 23 miles an hour? No. You can't get from 0 to 16 years old without at one point being 4 years old. Okay, so if the function is continuous over a closed interval and differentiable on an open interval, you are guaranteed that at some point from A to B, it's continuous and differentiable, there has to be at least once where the slope of the tangent line, where that instant is equal to the average. Does that make sense? You started at 0 miles per hour and you're currently doing 50 miles per hour, but your average was 40. There was some point in your trip that you were doing 40 miles an hour. Yeah? Mean value theorem. Crazy business. What if, how would this not work? How could we have a continuous function that went from A to B and the slope didn't have a time when the slope was equal to,
If it goes out of the constraints,
what constraint?
A to B.
Like, well, it still has to be a function, but is there a way that I could draw going from, I gotta be continuous, there's a tangent line that's parallel, how could I draw the curve where this theorem breaks?
Like a cusp.
Like a cusp. So if it's not differentiable, then we're gonna have problems. We could do the easiest thing, a corner. Okay, so that's mean value theorem. We get to throw Katie Harvey in jail because she's criminally speeding. It's my little happy pill. Okay, so there's practice for mean value theorem on delta knot. Could you guys start that now? It is homework if you don't finish it. And they used to have really evil ones with like doing it graphically. I did not need to assign those. If you find them, tell me. I did not intend them to be there. Oh,